Welcome back. In this video, we are going to solve a structural design problem that involves a cantilever beam design using working stress method based on eStructural Design Taichi found on the App Store. Design a reinforced concrete cantilever beam using working stress method with span of 9 feet, assumed width of 12 inches, and a balanced depth. The beam carries a uniform load of 600 pounds per foot and a concentrated load of 20,000 pounds at the edge of beam. Design criteria as follows. Strength of concrete 6,000 psi, main bars 1-inch diameter bar grade 60, stirrup bars 3/8-inch diameter bar grade 33. The beam carries a uniform load of 600 pounds per foot and a 20,000 pounds concentrated load 9 feet away from support. Assume a self-weight of 300 pounds per foot. Enumerate input parameters required. Name of beam CB12. Width of beam 12 inches. Length of beam 9 feet. Main bars 1-inch diameter at grade 60. Stirrup bars 3/8-inch diameter at grade 33. Strength of concrete 6,000 psi. Uniform load is 900 pounds per foot and concentrated load is 20,000 pounds. Given Fc prime equals 6,000 psi, Fs equals 24,000 psi, the balance section properties are as follows. N equals 6.568, K equals 0.425, J equals 0.858, R equals 492. Given W equals 900 pounds per foot, P equals 20,000 pounds, and L equals 9 feet, the moment from uniform load is 437,400 inch-pounds, and moment from concentrated load is 2,160,000 inch-pounds, for a total design moment of 2,597,400 inch-pounds. The effective depth is 20.97 inches, and total depth is 24 inches. Given M equals 2,597,400, Fs equals 24,000, J equals 0.858, and D equals 21.5, the area of steel is 5.87 square inches. The number of tension bars for 1-inch diameter is 8, and the number of compression bars is 2. The shear force is 28,100 pounds, and shear stress is 108.91 psi, greater than 85.21 psi. The total bar circumference is 25.12 for a bond stress of 60.64 psi, less than 371.81 psi. The design shear stress is 109 psi, and concrete capacity is 85 psi. Additional stress capacity from steel is 24 psi. Maximum spacing is 8 inches. For stirrup design, the steel region is 24 inches, web stress is 24 psi, and initial spacing at 13.75 inches. The stirrup spacing are as follows: 1 at 2 inches, 1 at 4 inches, 1 at 6 inches, rest at 8 inches. For 1-inch diameter main bars, use half-inch diameter stiffener bars. Design results are as follows. Fc prime equals 6,000 psi, Fs equals 24,000 psi, beam size is 12 inches by 24 inches by 9 feet, main bars of grade 60, at support, top bars 8 pieces 1-inch diameter bar, stiffener bars 2 pieces half-inch diameter bar, bottom bars 2 pieces 1-inch diameter bar, stirrups of 2 legs of grade 33, 3/8-inch diameter bar spacing, 1 at 2 inches, 1 at 4 inches, 1 at 6 inches, rest at 8 inches. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.